So we are all familiar to dielectric materials. First of all, we should place a question. What are dielectrics? In the case of insulating materials, electrons are tightly bound with the system. If you want to study the behavior of the insulating material in the electric field, that is called dielectric. Say the insulators whose behavior gets modified in the presence of electric field are called dielectrics. We can classify the dielectrics into two categories. One is isotropic and another one is anisotropic. If the change in dielectric is independent of the direction of applied field, the dielectric is known as isotropic. If the change in dielectric is depending on the direction of the applied field, the dielectric is known as anisotropic. Further, we may classify the dielectric material into polar dielectrics and non-polar dielectrics. In the case of polar dielectrics, a polar molecule is one in which the center of gravity of positive charges is separated from the center of gravity of negative charges by a finite distance. So we may point out that the polar molecules have permanent electric dipole moment. These are all the examples: HCl, COH2, NH3, CH, Cl3. So in the case of hydrogen chloride HCl molecule, the electron of hydrogen atom lies more closer or more towards the Cl atom. So the molecule is therefore a dipole having a dipole moment P directed from Cl atom to hydrogen atom as shown in figure. So the direction of dipole moment is towards hydrogen. So in the case of non-polar molecules, the center of gravity of positive and negative charges coincide. Therefore, they have no resultant dipole moment. The molecules H2, N2, O2, CO2, CCl4 are coming under the category of non-polar. If you think about this linear triatomic molecule CO2, in which the resultant dipole moment P equal to 0, because the P1 and P2 are in the opposite directions but are having same magnitude, so the resultant dipole moment P equal to 0, hence you can say that CO2 is non-polar.